इसके पप्पू बोले इसके पप्पू ऐसा मैंने होगा लग रहा है क्यों नहीं Just wait for 2 minutes. Okay. Okay, good morning everybody. Good morning guys. Good morning ma'am.
Good morning, ma'am.
Good morning.
Good morning. Okay, now what we have seen, last time we have seen the 386 architecture. We will just continue to that. I will just want to revise some few points, whatever we have done in the last lecture. We have seen the 386 features, that is, this 386 microprocessor is introduced in October 1985. Okay, these are the establishment uh, when it is established in October 19 with 8086, 8088, 186, 286 architecture. That means it works with the predecessor processor. Okay, this is the another feature of 386 microprocessor. The third feature, it has the clock frequency near about 25 megahertz to 33 megahertz. This is the clock frequency of 386 microprocessor. Now the size of the ALU, that is the arithmetical logical unit, is the 32-bit size. What is the size? That means the data, it is a 32-bit data processor. Okay, it has the 32-bit data. It operates on the 32-bit data. It has the 8 general purpose registers, and which having the size is the 32-bit registers. It has a separate 32-bit internal register, and it also has the 32-bit address registers also, or the address bus also. Now it has a 4 GB. That means it has a 4 GB physical memory. That means it can access up to the 4 GB memory. These are the simple some features of 386 microprocessor. Again, you have the more features in 386, that has the 3 operating modes: the real addressing mode, virtual addressing mode, and protected virtual mode. Okay, so these are the some features. Now I think we have already seen the architecture, but some points are remaining in that. So I just want to share my screen regarding that. I will show the diagram for that first. Okay. Now, in this architecture, the architecture, it has basically the 3 blocks. Okay, first is the memory management unit, second one is the bus interface unit. Okay, and it has the CPU, that is the central processing unit. I think my PPT is visible to you.
Yes, ma'am.
Okay, you just take the photograph of this so that you can understood, because I just want to change my slide so that you will get the which slide I am explaining. This is the architecture of 386 microprocessor. Now this architecture is divided into basically 3 units. First is the CPU. Okay, so which is the CPU? I think I have already explained in the last lecture. So this is the CPU part. Just wait. Okay, now this is the CPU part. See, my mouse is moving here and there. Just see, this is the CPU part. That means in CPU you have a arithmetical logical unit, you have an instruction pre-code unit and instruction pre-code unit. Okay. Now, this is the first part of 386 architecture. The second is the memory management unit. In memory management unit, you have these 2 blocks, that is the segmentation unit and the paging unit. These 2 blocks come into the memory management unit. And the third one is the BIU, that is the bus interface unit. That is the bus interface unit. In bus interface unit, you have the all the bus control. This is the bus control. So total architecture is divided into 3 parts. This is the CPU, this is the MMU, and this is the CPU. Sorry, BIU. Excuse me, the bus interface unit. Okay. Now the CPU consists of execution unit, here execution unit, prefetch unit, and instruction decoding unit. Okay. CPUs, that is this is the CPU part. This is the CPU part. So the central, I will just change my slide. Just wait, guys. Okay. I think I have already explained the flat model, segmented model. Just I thought I have a description over here, but let it be now. Okay. Now, here CPU consists of execution unit, prefetch unit, and the instruction decoding unit. Now, what is the function of execution unit? Execution unit, just go to the diagram and just see. It consists of 8 32-bit general purpose registers. We will go through this general purpose register one by one. Okay. And these registers are used for the address and data. It consists of barreler shifter. It consists of barreler shifter, which is used to speed the instruction or shift the instruction or divide or multiply operations. Okay. Now see, just go through this. Here I have written barreler shifter adder in the ALU. Just go through this. I will just make this PPT larger so that you can get it. Oh, okay. Now if it is exactly visible, let me know guys.
Yes, ma'am.
Okay, so this is the architecture. Now in the CPU unit, first is the execution unit, second one is the prefetch unit, and the third one is the instruction decoding unit. Now the execution unit, it consists of 8 32-bit general purpose registers for the address and data. It also consists of parallel shifter. Just go in here, here you have the parallel shifter is there. Now this parallel shifter is used to speed the shift, multiply, divide operations. Just go to here. These are the registers which may be 8-bit, 32-bit, 16-bit. Okay, and this parallel shifter is used to shift, rotate, and all the operations. So this is the execution unit. Now here you have the prefetch unit is there. Prefetch unit. That means what? Whatever the instructions from the outside that will be coming, okay, that will be get prefetched and that will be the decoded. That will be the decoded. Decoded means what? It is converted into the machine level language. See, whenever you are writing any code, it may be in assembly, it may be in C language. So the processor will not understood your language. You are getting? Processor will not understood your language. He has to convert that whatever the code, whatever the syntax you have written, that it has to convert it into a machine level language. Okay, it has to convert it into a machine level. For the C language, it is a binary file, and for the assembly language, it is a ASCII hex file. Okay, there. Okay, so whenever there is an instruction that will be prepared from the outside from the user, that must be decoded, and that will be done by done by the this one, this decoded and the prefetcher limit. Okay, now just 1 minute. लेक्चर चालू आहे नंतर फोन करते. Now next is the, so that part will be done by this that part will be done by the CPU. That is, that instruction gets decoded, that gets converted into the ASCII hex format. Okay. Now next is the memory management unit. Segmentation means what? Segment means what? It is a logical memory area. It is a logical memory area, and the paging is one, and that is the physical memory area. Physical memory area. So that these two unit will come into the memory management unit. The segmentation unit, it allows the conversion. It allows the conversion. See this unit. It allows the conversion of logical address to a linear address. Ata madam, logical address means actual address. Whatever you are, the RAM address. Okay, that is, see, whenever I have already explained you the example of the, whenever you are defining the variable C, it will take some place, it will take some space in the memory area. That is the actual logical space in your, in the processor memory area. Okay, so that is the logical to that is the logical. So that logical address must be converted into the linear address, and that will be done by the segmentation unit. This is the actually little conversion of logical address to linear address, that I will explain whenever I think in unit 3 is there. Okay. Now the page, also in paging mechanism, it allows the conversion, whatever the address is generated by the logical to by the segmentation unit, that will be converted into the physical address. That will be converted into physical address. So who will do this? That will be done by the paging unit. That will be done by the paging unit. That's why here you have the some descriptor registers are there. Page cache is there. Some adder is there. Okay. Please unmute yourself, all of you. Please unmute yourself. Okay. I think. Okay, so that whatever the conversion of the memory, that will be done by these two unit. Here some swash is there, swash. segmentation unit and the paging unit. Okay. Now the paging unit, there is actually some level of protection mechanism, some protected modes are there that will be in a unit 4, I think so. Okay. Now next, bus interface unit. Bus interface unit. Now this is the bus interface unit. This is the bus interface unit. Now what it handles? It handles all the external access and it gives or it provides the addresses and generating the respective control signal. Respective control signal. Okay, that means it control all the signals. Just see here, there is a request for the this particular processor. Here you have the request. These are the name of the pin: hold, INTR, error, busy. This is the pin of 386 processor or the IC. You can see. Okay, so that will be the input to the BI. Even you have the some byte enable signal is there, address is there, then you have the read, write bar, log. Then these are the pins. These are the pins in the function for that particular, each having their own functions. Like for the read operation, that is it can read the data from out to the memory. Okay, write, that means it can write the data to the memory. These are the different functions of these pins. Okay, now these functions it handles, now in short, it handles all the what you can say access, external access. These are the signal according to that. See here, it generates the control signal. It has the, whenever it has the memory read write, it has the bus pipe. It has the control to the internal control bus. Even it has the control to the transceiver. That is the here. That means whenever you want, the processor want to transmit or receive the data, it has the control over. That means what? Bus interface unit. It control all the external access. Understood? Have you understood this architecture? Let me know, people. You are getting, guys? Or shall I repeat it again?
Understood, ma'am.
Understood. Okay. Now the next one is the now next part, that is the programming model. In programming model, next point is the programming model of 386 microprocessor. Okay. Now in the basic what do you mean by programming model? What do you mean by programming model? The programming model is nothing but the overall organization of the processor. Overall organization. Now here you have in this programming model the memory organization and segmentation, some data type, registers. You should know the instruction format. Then you have the operand selection and the interrupt and the exceptions are there. Okay. So all these whenever you get it together. So this is the another point according to the syllabus. Okay. So here you have. Okay. Now here you have the programming model. It consists of, first is the memory organization or the segmentation, second one is the data type, then registers, then the instruction format, then you have the operand selection and the exceptions. We'll go through one by one. Now first is the memory organization and the segmentation. Now the physical memory of 386 microprocessor is how it is organized. It is organized as a sequence of, just see here, sequence of just wait, and it's getting. Okay. Now the physical memory, or how the memory is organized. The physical memory of the 386 microprocessor is organized as a sequence of 8 bytes. Okay, as a 8 bytes. Now each byte has a unique address. Each byte has a unique address. So 1 byte is equal to how many bit?
8.
4.
8, not 4 guys. 8 bit is equal to 1 byte. Okay, so the physical memory of the 386 microprocessor is organized as a sequence of 8 bit bytes. Okay, each byte has a unique address. आता each byte म्हणजे 1 byte is equal to 8 bit. म्हणजे 8 bit is a unique address for that particular memory. Get it understood, guys? Okay, just I will. बघा इथे I just want to. 8 minute. See guys, I am drawing over here. My screen is visible to you, all of you? Screen is visible?
Yes, ma'am.
Yes, ma'am.
Okay. Now here I have a 0 to 7. That means 8 bit. Okay? That means 8 bit. And this whole 8 bit is a 1 byte. Okay? I am not writing for just you. I think you should get it. This is a 1 byte. Okay. Now each byte. Here you have the linear address space, which is indicated by the 000, which is indicated by the 000. That means it has an address range started from the 00. म्हणजे हा unique address झाला तुमचा. That means the memory चा. Okay. Now if you have this something like this, okay, then it is 1. That is 0001. Then here you have the 2. So this is a linear address space. Okay. So each byte has a unique address range, and it has it is started from the 00, and it has up to 2 raised to 32 minus 1. That is the 4 gigabyte. So 80386, it has the physical address space. That means whenever you are writing the programs are written where you are written, and that will be considered as a physical memory available. So whatever the program you are writing, that will be the physical memory. Of the processor. Okay? So this is the memory organization and the segmentation. This is the 1 point from your programming model. Now in this organization you have the flat model and segmented model. So in a flat model you have 2 raised to 32, that is the 4 gigabyte, and the physical memory it contains up to a 4 gigabyte. And the processor will map the 4 GB flat physical address space. 4 GB physical address space. Get it understood? म्हणजे ही जी physical memory आहे, आता actually whenever you are writing the program, at that time it will take the 1 linear address space. So that is the nothing but your physical or the processor physical memory. Okay, so it near about the 4 GB. Now here. So this is the flat model, and the segmented model means what? You have the small parts are there. That means the memory is divided into small partitions, and these small partitions, okay, these small partitions are actually converted into the linear address space. That will be the case in 386 microprocessor only and onward microprocessor. But for 8086, it is not something like that. It is a code segment. It is a data segment. Okay, so that will be the segmented model. Now next is the, have you understood this segmented, the first point, memory organization and segmentation? Yes, let me know guys.
Yes, ma'am.
Okay. Now the next PPT. I think let me erase all the things. It will come. Okay. No. Flat and segmented memory model. Okay. The flat address space consists of single array of 4 GB. Just now I have already explained. And the segmented address space consists of collection of up to 16,383 linear addresses. Okay. Now the next. Flat model, same thing, whatever the explanation I have given you, just go through this, whatever I have explained you. This is the segmented model, that is the 2 raised to 46, that is the 64 tetrabyte. Okay. Next point in a programming model, that is the data type. What do you mean by data type, guys? What do you mean by data? What do you mean by data?
Information.
Information. Okay. Anything more?
Ma'am, set of
Info.
values in a particular format.
Set of, yes, set of.
Set of values or facts or figure in a particular format.
Okay, set of a value in a particular format. The data is nothing but the information, or the you can say a variable. You can say a variable. Data is something like the set of information. Set of information that will be defined by the user. Okay, and types means what kind of type, what kind of nature it has, what kind of nature it has. For example, you have an integer, you have a string. These are the different data types. These are the different data types. Okay. So the fundamental data types for the microprocessor is a byte, that means 8-bit, words and double word. These are the very basic fundamental types. These are the very basic fundamental types in 386. Now see, here you have the byte. Byte means you have the 8-bit, word means 16-bit, and double word means it is a 32-bit. Just go to this slide. Mm. एक minute, just wait. I will show you the. Let me close. Is it visible now? Is it visible, guys, properly?
Yes, ma'am.
So this is the fundamental data type. First is the 0 to the byte is there, word is there, double word is there. The size of the byte is the 8-bit, then word is 16-bit, and double word is a 32-bit. Okay. Now next is see how you can represent that byte, word, and double word in a memory. Now see here, you have a byte means what? 8-bit. Byte means what? 8-bit. So word at address 31. See 0 0 0 0. This is the 8-bit. That means 1 byte. I have already explained. This is the linear data. This is the linear or the physical memory address. This is the physical memory address. So here you have a just to see word at address contains it is a 31, word at address 9. Okay, that is 1F. It is started from 0 0 0 1 2 3 4 5 6 up to 9. After 9 it has a not a 10, it has a A, okay, which is a hexadecimal numbers. That's why it is A B C D E and E. It takes the space from here. It will take the space from here. Whole linear address. It takes the whole linear address. Okay. Understood, guys, this? Now the next. Additional. These are the basic data types, that is byte. The additional data types is a integer, ordinal, near pointer, far pointer, string, bit string, BCD and packed BCD, that is the binary coded decimal. Okay. Now here we will see one by one. 80386 data types. First is the byte, second one is the word, third one is the double word. Then here you have the what I can say, a bit pointer is there. Okay, like before pointer you have some, just okay, integer is there. Integer means what? The any numerical value. Okay, the integer means what? It has the any numerical value. Now the pointer, that means it has the 32-bit logical address. It has the 32-bit logical address. And the pointer means it is a offset within the segment. That means offset means first it is some kind of address is there. So that address will be within the segment. Okay. See guys, these are the some little bit difficult concepts. If you have any doubt, you can ask me, because the microprocessor subject is little bit hard. Okay, you won't understood whenever I am teaching you. But if you have any doubt, I will repeat it again. Okay, but get it understood very well. Now, near pointer. Pointer means what? It is a 32-bit logical address. It is a 32-bit logical address. And the near pointer, it is an offset within the segment. It is offset within the segment. Now, this near pointer is used for the flat or segmented model of the memory organization. Okay. Now this is the near pointer, and the far pointer is a like the pointer only, like this offset within the segment only, but it has the logical address near about 48-bit. It has the logical address near about 48-bit. It has the 16-bit segment selector component. It has the 32-bit offset components are there. Okay, so this is the near and the far pointer. This is the near and the far pointer. I have shown you. No, I haven't shown you. Let me know. 32-bit, 48-bit. Okay. So the pointer is nothing but what? You have a offset address. You have the offset address. And that offset address, where it is present? It is present in the segment. When it is in the same segment, that will be the near pointer. And when it is in another segment, then it is a far pointer. Okay. String data type. Next is the string data type. String data type, like you have the continuous sequence of byte word. एक minute. Okay. So okay, string data type means a continuous sequence of byte word or double word, and define the string according to your application, according to the user. 1 byte, 2 byte, 3 byte, 4 byte, etc. String data type, the string data type I already finished. Now next is the BCD, that is the byte unpacked representation of a decimal digit in a range from 0 to 9. In a range from 0 to 9. Okay. Now the BCD, that is the byte, it is a representation of a decimal digit which ranges from the 0 to 9. Okay. Now here you have the unpacked decimal number which are stored as an unsigned byte quantity. One digit, it will be represented in a byte, and that will be the store, whatever the one digit that will be stored, that is in each byte. So the magnitude of the number here you can find out. Don't go for the magnitude, just remember BCD. Okay, because it is the byte BCD. What you have here? 9 decimal digit in the range 0. Now next is the, in BCD you have the packed BCD and packed BCD. The packed BCD means it is a representation of In a pack you have the representation of the 2 digital number, okay, and which having the range चांगली ये ठेवते मी लेक्चर चालू okay. Now where we are packed BCD. So this is the packed BCD. It has the representation of 2 digit decimal digit, which is range from the 0 to 9, which is range from 0 to 9. So this is the another data types. Now one is the ordinal. Ordinal number means what? You have first, second, third numbers which are used for the adjective, noun. So that kind of data type also available in the microprocessor. That kind of data type also available in the microprocessor. Now next is the, see, we have seen integer, ordinal, near pointer, far pointer, string, bit field, bit string, BCD and packed BCD. So these are the data types of 386 microprocessor. These are the data types. See, I will repeat it again. First is the bit, byte, word, double word, then you have the integer, ordinal, near pointer, far pointer, string, bit, field, bit string, BCD and packed BCD. So these are the data types. The question will come. Ordinal is something like the whenever you want to define some characters, okay, or whenever you want to define some like the position, like I say in a string operation. Suppose you want to calculate the particular position in the string for the particular character in the string. At that time you may need it, okay.
Yes, ma'am.
And that variable you can define in the string format. That is the ordinal. Okay, that may be in a like the pointer. Okay.
Yes, ma'am.
Anything more? Anything more? Got it now? Yes, understood, guys?
Yes, ma'am.
Have you understood, guys?
Yes, ma'am.
Yes, ma'am.
Okay, thank you, Vipul. Now the next point is okay. Now the registers. I think about 10 minutes are there. Okay, I will continue with the registers. Okay. Now the next point in the programming model is a register. Okay, in a register. First is, what is the first point? What is the first point in programming model? Okay. First is the memory organization, okay, and the segmentation. Second one is the data type. Third one is the register. Now, the registers, 80386 contain the 16 registers, okay, that we will see one by one. Now, that will be the registers are used for what? Anybody know what do you mean by register? Dell मध्ये झाले बघा. What do you mean by register? I want an answer from you. What do you mean by register? What do you mean by register? काय रजिस्टर हा वर्ड ऐकलाय की नाही अगोदर? What is the function of register? Registers. 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 Nobody know what do you mean by what is the function of registers? Registers. बरोबर आहे, बरोबर आहे. No, you are right. Registers are the type of computer memory. Okay, आता बघा तुम्ही मदरबोर्डवर you have some different registers are there. ठीक आहे, म्हणजे एक टाईपची मेमरी आहे की ज्याच्यामध्ये तुम्ही काही कंटेंट स्टोअर करून ठेवले जातात. So like you can store the voltage, the voltage can be stored ना, बरोबर ना? Zeros and 1 असतं. मग कम्प्युटरला which language the computer understood? Zeros and 1 only. Okay, so the registers are the type of computer memory and which is used for the storing purpose. The data may be used for the instructions, may be used for the that means you can quickly accept or transmit the data. Okay, so for that purpose the registers are used. Get it? I have understood. This is the function of register. Now there are three categories of the register. One is the general register, second one is the segment register, and third one is the status and the instruction registers. Okay, understood? Understood?
Yes, ma'am.
Now general purpose registers. There are 32-bit general purpose registers and which are used for the primary to contain the operand for the arithmetic and logical operations. Okay, very primary registers, that is AX, BX, CX, DX, then the base pointer, stack pointer, source index. So which are the general purpose registers? EAX, BX, CX, E for what? E for extended. Okay, whenever there is a 32 creates a 32-bit processor. That means the size of the processor, the data size of the processor is a 32-bit. That means the extended. And for 8086 it is a AX only, BX only, CX only. Okay, now ठीक है. Okay, the general registers are 32-bit registers and EX, EBX, ECX, ABX, EBP, ESP, ESI, EDI, that is the extended. E for extended. Maybe in the oral they will ask what do you mean by EAX. So E for extended. Now these are the registers which are used for the arithmetical and logical operations. Okay. Now the next one is the segment. Special purpose registers which has the system software designer which will choose either the flat or the segmented model. The flat model बघितलं, segmented model we have seen. Now, determine at any given time which segment of the memory is currently addressable. म्हणजे see, whenever you have a core segment, you have a data segment, you have a stack segment. So what it will tell, it will address the current memory, okay, current memory, which is the current memory. That means suppose you have written one variable, okay, so at which segment of the memory is addressable, that kind of information will be given by the segment register. Okay, so there are near about 6 segment registers: code segment, data segment, stack segment, extra segment, then fs and gs. Now these are the 6 segment registers which are used in the 386 microprocessor. Now see here, what is the size of the segment register? It is a 16-bit. For the general purpose, it is a 32-bit. Whatever the explanation I have explained, I have just put it in my diagram. That I have just put in my diagram. Okay. See, here this is a 0 to 16, 0 to 15, that means 16-bit. So it is a 8086 microprocessor. Okay, but we are going for the 386 microprocessor. See guys, whenever I am explaining each and every concept, I am telling the difference between 8086 and 80386 microprocessor. So get it understood. There may be question like explain the difference between, argue the difference between the 8086 or the 386 microprocessor and the say 386 microprocessor, or the question is something like that, give the difference between 16-bit processor and the 32-bit processor. Okay, the answer for this question, this is the another. Now next is the segment register. Just go to the segment register. You have a core segment, stack segment, data segment, extra segment, fs and gs. So here you have the module. Here you can have the, that is data segment will be given to the one register. Again here, again these are the different modules actually, programming modules. Okay, that you can point to the segments. That will you can point to the segments. Now the flag registers. I think I will cover this flag register in the next lecture because I have to explain this very well. Because whenever you are doing the programming, you should know which flag will be set, which flag will be resetted. Okay. So till now, any doubt? Have you got it? If you have any doubt or you haven't understood any concept, I will let me know. Shinde? Yes, let me know guys. Have you understood?
Yes, ma'am. No doubts.
Okay. Okay, so thank you. Thank you. Take care.